Okay, let's make a start. Hello, folks. Welcome to my presentation on cf-for-k8s 1.0. As you may know by now, we hit this amazing milestone this week, and I'm delighted to be here talking to you about that today. So, standard disclaimer before we start, this presentation is intended for educational purposes only. Everything in here is, to the best of my knowledge, accurate, but if you do find some discrepancies, then they weren't intentional, and I apologize in advance. So, who's speaking today? Well, my name is Paul Warren, and I work for Vmware. And I have had the pleasure of working with Cloud Foundry for about 5 years. I first started on UAA because I'm a Java guy, and at the time I also worked for EMC, so I helped propose and latterly implement the volume services feature that we know in Cloud Foundry. And I stuck around on that team for quite a while, in fact. And then I rotated onto release engineering, initially as an engineer, and then subsequently as product manager. And therefore, I am currently responsible for CF deployment product and for cf-for-k8s that we're talking to you about today. So my agenda, well, I don't really have one. We're kind of going to go on a journey and look at the development workflow from the perspective of someone using Kubernetes directly and someone using Cloud Foundry directly. So let's make a start. Let's start with Kubernetes. An open source container orchestration system has become the de facto standard and key enabler for cloud native applications and the way they are architected, composed, deployed, and managed. Enterprises are using Kubernetes to create modern architectures composed of microservices that scale massively and seamlessly. Kubernetes is great. It's amazing, in fact, making what was once very difficult now very possible. It is, in essence, an entire ecosystem of tools: networking, load balancing, object storage, compute, and memory allocation and scheduling, all working in concert to make the difficult possible. But operating and using this set of interconnected tools, particularly in production settings, is hard, and much as we would like it, there is no such thing as a self-tuning, self-healing, self-administering Kubernetes cluster. So to understand just some of the complexities of Kubernetes and conversely the benefits of Cloud Foundry, let's take ourselves on a journey comparing and contrasting a developer's experience with both. A quick note: as we walk through this presentation, I may present some workflows as those of the developer using Kubernetes. To the best of my knowledge, these workflows are accurate and do need to be performed, but not necessarily by the developer. This was done to hopefully improve the flow of the presentation. But first, let's make a quick pit stop to take a look at the differences between the deployment experience of cf-for-k8s and CF-VMs. Let's look at it from the platform operator's perspective. When we're deploying Cloud Foundry on VMs, we use a tool called Bosch Bootloader, which is Bubble for short. We bubble ourselves up some infrastructure on the cloud of our choice and a Bosch director. This usually takes between 30 minutes and an hour. Whilst that's happening, we can git clone the CF deployment repository. This contains all the files needed to deploy a Cloud Foundry. It also comes with a set of ops files that you can apply to your deployment if you would like to change the shape of that deployment. We may also need to provide some of our own. We collect these ops files together and we do a Bosch deploy with them. We wait a further 1 to 2 hours, at the end of which we'll have a Cloud Foundry deployed on a bunch of VMs. So total time there is about an hour and a half to 3 hours, depending on the size of your deployment. Now compare that to cf-for-k8s, where we need to first create ourselves a Kubernetes cluster. In my experience on GCP anyway, that usually takes between 5 and 10 minutes for a reasonable sized cluster. Whilst that's happening, we can git clone the cf-for-k8s repository. Now with cf-for-k8s, we made the decision not to provide any ops files. Instead, you need to create yourself an installation file with all of the properties set to the values you want to create the shape of the deployment that you would like. Once we've created our install file, we can then do a cap deploy, which is the new Bosch deploy, and we'll talk a little bit about cap in a minute. We wait a further 5 to 10 minutes for a total time of about 20 minutes, at the end of which we'll have a Cloud Foundry installed on the Kubernetes cluster. I think you will agree that we see dramatic improvements here. Within the component teams, within the foundation, we were very excited when we first started seeing these sorts of times emerge. I remember countless messages being posted to Slack when the next person that hadn't installed cf-for-k8s before did so for their first time and were blown away by how quick it was. It was a very exciting time. And this is important to note that those timings are for a first product install too. An upgrade is dramatically quicker than this. So let's actually have a look at that for ourselves. So we're in the cf-for-k8s repository that I've git cloned here ahead of time, and the first thing, and so the top window is my CLI, and the bottom window is K9s, which is a really cool tool for navigating Kubernetes clusters. And we're just going to flick between the two and see things happening as the deployment progresses. So the first thing we said we need to do was create an installation file. Now, in the hack directory of cf-for-k8s, there's a generate value script, which we use all the time, and you're free to use too, that will generate you this installation file pretty much. It takes two parameters. The first parameter, -d, indicates the domain that you wish to associate with your deployment. And this is mandatory. You need to supply this. Second parameter, -g, is pointing to the keys for a Google container registry. Now, this is for convenience for us because we deploy on GCP for the most part. This is optional. You do not need to supply this, but cf-for-k8s is a bring your own app registry. So if you don't point to a GCR, then you need to go in after this is generated and add some app credential registry credentials following the docs will show you how to do that. I'm not going to run this because I did it ahead of time. I'm not going to show it either because it's got real certificates and so on and so forth in it. So you'll have to believe me. So we can move on to the cap deploy. And the first thing we'll notice here is actually there's two commands. There's a YTT command and a cap command. So both of these tools come from Carvel, which is formerly known as K14s. And it's a set of tools that help you build and install applications onto Kubernetes. So the YTT is run first. We're supplying this two parameters. The first -f config is actually pointing to the config directory in the cf-for-k8s repository here. And that is a set of templated Kubernetes YAML. The second parameter, the second -f, is the installation file that we created with the hack generate value script. And essentially what happens here is YTT takes the installation values from the installation values file, and it kind of injects them into the Kubernetes templates to make them real Kubernetes YAML. And it kind of renders all that out to standard out, which kind of pipes it onto the second command that gets run, which is the cap deploy. And so that takes all this Kubernetes, rendered Kubernetes YAML, and we're telling it here to take all that and deploy it into the Kubernetes cluster that we're attached to and call that deployment CF, which is what the -a CF argument is all about. So I'm going to go ahead and run this. And what's happening now is it's the same command. You do this cap deploy command for a first product install and for an upgrade. So obviously cap goes away here, and it compares the rendered YAML that you've given it against what's out there in the cluster and figures out what it needs to create, what it needs to update, what it needs to delete. But in this case, it's a first product install, so everything is set to create. You can see there's a big long list of things, and it's quite interesting to read. So I encourage you to look at that. So I'm just going to hit yes here. Now in the bottom window, you can see we're looking at namespaces, and immediately you can start to see some action. So CAP is moving ahead with the deployment and deploying a bunch of namespaces. So I'll just call some of these out. CF workloads is where your workloads will ultimately run. CF workload staging is the staging area for your images on the way to them being real apps that run on the cluster. We've got a blob store and a DB namespace there. If you don't provide your own, we'll deploy some single instance on the cluster for you. CF system is where most of the system components run. And then we've also got KPack, which is our kind of source to image system. So let's dive into CF system, have a look at the pods in there, and you can see there's a bunch of things going on that are all different colors. And this is kind of, you're seeing Kubernetes at work here. So it's an eventually consistent thing. So what CAP's kind of done is thrown everything at Kubernetes, and it's all happening at once, and eventually it will converge and become good. So that basically is the deployment, and it will take around 10 minutes. So we'll check back in with that later. All right, moving on. So let's have a look at the architecture real quick. As you can see, with cf-for-k8s, the system components and the application workloads that are CF pushed by developers all end up running on the Kubernetes cluster. To those that are familiar with CF, as we cast our eyes over the architectural diagram here, we see lots of familiar names. But all components have undergone either a containerization effort to make them Kubernetes native, the Cloud Controller and UAA being two good examples of this, or they've undergone a complete re-architecture. And of particular note here are the networking, logging, and metrics components that are now lean heavily on CNCF projects such as Istio, Envoy, FluentD, and Prometheus. Finally, some components are completely new, those being KPack, Paketo or Cloud Native Buildpacks, and Irene. Excuse me. We'll touch upon as many of these as we can as we move through our presentation. Now, some components you have to bring with you. Excuse me. Trying to get my mouse situated here. Now, some components you have to bring with you, those being a load balancer and app registry. Others you can bring your own if you would like. cf-for-k8s is configurable to use an external database and blob store, but it will create its own single instance deployments of Progress and Minio on the cluster if you don't, and we saw that happening in our deployment just now. So batteries are included here. We are really trying to make CF accessible this time around, and actually one of the things I would like to look at is doing the same for an app registry as well, so you don't necessarily have to bring that. Now, as we touched upon, cf-for-k8s is deployed with an entirely new toolchain called Carvel, formerly K14s. And Carvel provides a set of reliable, single-purpose, composable tools that aid in your application building, configuration, and deployment to Kubernetes. We think you're really going to enjoy these. We've enjoyed using them so far. Okay, so let's start our journey. Back to our comparison. We have a couple of developers, Kubernetes Kevin and Cloud Foundry Cody, with K of course, and they've been hard at work on an MVP of their application, and they're ready to deploy it. Let's take a look at their experiences. Kevin, who's using Kubernetes directly, needs to create himself a deployment. He chooses a replica set, so he creates replica set YAML. He messes with this YAML a bit to get it right. Your mileage may vary here, depending on how familiar you are with the Kubernetes API. He realizes, as part of this, that he needs a container image. If he needs a container image, then he also needs a container registry to host that image. So he procures access to a container registry. He builds his app to put in the image. He creates his image with a Docker file. He Docker builds, tags, and pushes that to a container registry. That gives him a reference to the image, which he then puts in his replica set YAML, and finally he can kubectl apply that to get his deployment. From a Kubernetes perspective, there's a lot of steps here. most of which can be automated, of course. But let's bear in mind that we are not the only development team. Our organization has many. Each team needs to go through this process for their applications and their services. Now, when we compare this to cf-for-k8s, where the developer simply has to change into the directory that contains his source code and run cf push. So let's take a look at that. Okay, so our deployment is completed here, 9:53, it's finished, and let's see, I forgot to time this, but we can whiz up here real quick. There we go, 9:46, so about 7 minutes, I think, and we're done. So great. So now I need to target the API. So I templated this command because I deploy cf-for-k8s a bunch of times to a bunch of different clusters. So I've done this for my own benefit, but all I'm doing here is targeting the API, obviously, and then I'm authenticating, grabbing the admin password out of the input values file that we created earlier. And then obviously we need to target an org. So I'm just going to target the system org for ease, and I'm going to create myself a space called S. And then I'm going to retarget the org to put myself in that space. And when I'm in that, I can then change into the famous Spring music directory, and I can simply run cf push. And off that will go. And of course, what's going to happen here is it's going to load all the application bits up to the cloud controller, is going to put them in app registry, and then it's going to do all of the source to image stuff and then schedule that to run in CF workloads namespace. We'll come back and have a look at that a little bit later. Moving on. Okay, so Kubernetes. In Kubernetes, Kevin had to do a whole bunch of stuff there, as you can see, and Cody actually just had to run cf push, which we've done ourselves. So there's a lot of magic going on. So how does that happen? Well, it happens with, I've lost my presenter notes here. There we go, I've got my presenter notes back. So CF integrates a new component called kpack, which is the open source component of the Tanzu build service from VMware, which in turn uses cloud native Buildpacks, which you can find under buildpacks.io, to orchestrate the source to image process, whereby it detects your application's language, builds and combines that with the relevant runtime components, a Java application server in our example, for example, builds the product of this into an image and uploads that to the container registry that you provided to the deployment. A further capability that this integration provides for is the management of the base runtime of these images, the OS that they were built from. To illustrate this point, perhaps let me ask how Kevin would deal with an OS vulnerability. Not too difficult, I suppose. He'd rebuild the image from a base OS image with the fix and redeploy his application. Not to labor an earlier point, but how does your organization manage this across all of your development teams, especially if there are SLAs that your organization needs to fulfill for its customers? Cloud Native Buildpacks gives the platform operator of cf-for-k8s the ability to patch the base runtime image of all currently pushed applications, and of course of any that will be pushed, with a single command. With cf-for-k8s, the operator doesn't have to coordinate with each and every development team. They don't even have to wait for a new release of cf-for-k8s. As soon as CMB releases a new runtime image, you can apply that with a single command to your deployment and it will update everything. Pretty neat and a great value add of the platform. Furthermore, if we compare the capabilities of CMB to the current set of competitors out there, we see that that is far and away the most superior offering out there, and you get all this free with cf-for-k8s. So KPAC and CMBs handle the source to image side of things. A third new component called Irene handles the scheduling. So let's take a brief look at that. Project Irene is an incubating effort within the Cloud Foundry Foundation, enabling pluggable scheduling for Cloud Foundry. Essentially, it provides a scheduler abstraction that we call the OPI, or Orchestrator Provider Interface, an implementation of that interface called Irene that knows how to schedule applications and tasks onto a Kubernetes cluster. Now, we retrofitted the OPI to the Cloud Controller, so the Cloud Controller now coordinates with the scheduler via this interface to place its workloads. When asked by the Cloud Controller, Irene combines the image previously built by KPAC using CMBs with additional metadata such as the services that need to be bound into a properly configured stateful set in the CF workloads namespace. And all of this replaces Diego, Cloud Foundry's original container scheduler. So our app is deployed. Let's test it. Kubernetes Kevin opens a browser. He realizes that he needs to set up Ingress because you don't get that for free with Kubernetes. So he creates himself a service resource of type load balancer. kubectl applies that. He waits for the service to be ready and gets the load balancer IP. He then goes and updates his DNS with that load balancer IP. Finally, he's able to visit http myapp.mydomain.com, at which point he realizes he forgot to set up TLS and he bookmarks this for later. Kevin has to perform a fair number of steps again. Fortunately, these are one-time only steps, but there are most definitely variations on a theme here because not all infrastructures are created equal, and there's also a bunch of different ways to get traffic into your Kubernetes cluster. Additionally, app routing is being handled per application here, and scale this approach up to your organization again, and you have a lot of load balancers. cf-for-k8s handles routing as part of the push. Our integration with Istio automatically creates a route for your application that leverages the platform's load balancer, DNS, and certificates. So let's go back and check on our deployment, see where it's at, and have a look at that. And we can see we have deployed. So I can go ahead and grab URL here, and perhaps before we'll look at that, we'll go back to our namespaces here and we'll head over to the CF workloads namespace. And you can see there's a Spring Music pod here, and this is backed by a stateful set. And this is actually the Spring Music app running. And I can dive into this a little bit, have a look at the logs, and you can see it looks pretty springy to me. So that looks good. So perhaps let's open a browser. That was my last go. Let's open a browser here and punch in the Spring Music, the route. And hey presto, we enter the Spring Music application. And as I mentioned earlier, we reuse DNS and certificates. So if we have a look at the certificate here, you can see, we've made a deployment here with real certificates, and this is a real valid certificate here when we try and access the app. So cool. All looks good. We get Ingress for free. So let's return to the presentation and move on. Let's have a quick look at Istio. And I've lost my slide presenter notes again. Okay, presenter notes back. Sorry about that. So let's have a look at Istio. How does that work? Well, we re-architected our networking stack onto the CNCF projects of Istio and Envoy. As you have seen, our integration automatically maps a route for every application that you push, but it does more besides that. It also encrypts all east-west traffic between our system components with automatically rotating certificates that you don't have to worry about, so it's secure by default. And unlike Kubernetes, where traffic between pods is open by default and typically not what you want, especially in a multi-tenant cluster, cf-for-k8s creates network policies to deny traffic between pods and namespaces outside of the ones it knows about. So again, it's secure by default. So moving on, that might have been more work that Kevin was expected, and that's all time away from coding for him. But Cody hasn't had to worry about any of these concerns and was able to get straight back to it. The very next thing that their MVP needs is a database, of course. But Kevin is not deterred by his experience so far. He really wants to use Kubernetes, so he is going to have a go at deploying the database on cluster. So he finds a suitable DB Helm chart. He realizes that a database needs persistent volumes. He installs or gets access to a SAN more likely, realizes that he needs the CSI plugins for that SAN installed into his Kubernetes cluster, so he figures out how to do that and does it. And finally, he's able to Helm install the DB chart and he has a database. But he's been thinking and he realizes that databases usually need dedicated hardware or strong SLOs at least. And he realizes that databases are basically hard to run at scale. So he Helm uninstalls the DB chart and he deploys a cloud provided offering instead. As it always has done, on the other hand, Cloud Foundry offers a marketplace of services from which users can provision reserved resources on demand. Examples of resources services provide include databases on a shared or dedicated server, as in our example. Acquiring a database is as easy as create service, and connecting that to your application is as easy as bind service, especially when combined with the many app connector libraries that exist. But in Kubernetes, you have a lot of decision making to do. To this day, running databases on cluster remains a very hotly debated topic. You may well be better with a cloud database. Now, fortunately for Kevin and Cody, the app is gaining some traction, so they have scaled it to 5 instances. But some of their users are now reporting problems, so Kevin and Cody need to debug. Kevin dives in with a kubectl logs -c and tries to grab the logs from one container. He realizes that he has no idea which container the users would have been using when they experienced this problem. So he attempts to search the copious logs for each container in turn. He decides that there must be a better way. Thinking about it, he decides he can label his pods in his replica set. So he goes ahead and does that, waits for the problem to manifest itself again, and when it does, he does a kubectl logs, but this time with a -l and the label, and he is presented with the logs from all containers. Now this is better, but it's still suboptimal if you need to do complicated debugging, so he starts to investigate a log management integration. Ultimately, if you are using Kubernetes cluster directly, then you will sooner rather than later need to install some log management solution. This means picking one, and that's no small task. There are many out there. Splunk, Logstash, Graylog, FluentD, CollectD, FileBeat, Prometheus, Kafka, Elk. I could go on. Once you've picked one, you then need to deploy and successfully operate this. With cf-for-k8s, logging has been completely re-architected onto FluentD. So not only have we made the choice for you, but we deploy, operate, and integrate that into the platform, allowing you to get a single view of your logs across all containers, no matter how many instances you have scaled to, with a single cf-logs command. Moreover, you can also tee app logs to your organization's log management suite as and when you need to. And with metrics, it's a similar story. Setting resource requests and limits is very, very important in Kubernetes to allow the scheduler to do the best job possible with the resources available to your cluster and therefore with your hard-earned dollars. When using Kubernetes directly in a multi-dev team setting, you are competing for resources with all of the other dev teams. Not setting anything is not an option, as that puts your app first in the queue of pods for eviction when things get tight. So at some point, sooner rather than later, you will need to consider your application's metrics, not to mention those of your cluster, as well as your log management. That means you need a metric solution alongside your logging solution. And again, you can go the DIY route, or you can use cf-for-k8s with its built-in Prometheus integration. And I urge you to attend the metrics team up and running with Prometheus in cf-for-k8s talk for more information on that. So hopefully by now we are realizing that Kubernetes is harder than it first looks. And we've really only just scratched the surface, to be honest with you. If they really want to run a Kubernetes cluster in production serving multiple development teams, then Kevin still has a lot of work to do. Kubernetes just doesn't come configured for this. Kevin would also need to consider namespace isolation using network policies so that teams have access to their namespaces only. Resource limits with limit ranges and resource quotas so that teams don't starve other teams or in fact the cluster out. He'd need to consider security limitations with pod security policies and pod security contexts. Should teams be able to deploy containers that run as root, for example? You would need to consider network policy isolation so that teams' own deployments can communicate, but not with other teams' deployments. And possibly he would also need to consider node isolation with node affinity and anti-affinity, giving priority to certain teams' deployments that need access to special hardware available on certain nodes, whilst keeping other teams' deployments away from those nodes. Alternatively, cf-for-k8s organizes tenants around an orgs and spaces model with role-based access control. Now, whilst these constructs don't map down onto the underlying Kubernetes cluster just yet, something we will continue to evaluate and improve moving forwards, this does work out of the box, and many organizations have used it successfully to support multi-team development within their enterprises. So, if you're an operator already familiar with CF, give it a go and see how quickly it now deploys and upgrades. We think you'll be really pleasantly surprised. If you're a developer already familiar with CF, give it a go and you'll see that it is the same CF that you've been used to. Importantly, it is the same CLI. It is still CF push, which means your CI/CD should largely be unaffected by the switch. If you are completely new to CF, give it a go and experience the famous CF push for yourself. cf-for-k8s now installs on a laptop. With our tutorial, you can go from 0 to push in under 30 minutes. There really is no reason not to give it a go. So we've reached 1.0, a huge milestone for us, but are we done? Well, absolutely not. There is still lots of things we want to do, in no particular order. At the moment, scaling is an exercise left to the operator. We provide documentation, and luckily in YTT we have a tool that allows for this customization. But moving forward, we want to explore the various scaling interfaces that are now possible and offer the most suitable one to you. We would also like to move secret managements onto the platform so that it isn't an out-of-the-box activity like it is today. And a note on that, there are also some secrets that we can't rotate right now. So please check our documentation and issues for details. Now with CF deployment, we have a concept, I should say, of stem cells and releases. This allowed us to respond to CVEs very quickly by patching all system VMs with a single bosh deploy command. However, in this new brave world that we find ourselves in, we don't have stem cells. But we are still committed to providing you with the same SLOs in this regard, and image management is the track of work that we are undertaking to provide the ability to rebase system images onto new base OS images as and when the need arises. So please look out for that in our GitHub project. We want to continue to embody the community's opinions and best practices on operating a multi-tenant Kubernetes cluster by distilling these into the product that is cf-for-k8s. And of course, we want to continue to create a more componentized, open and extensible platform. And as you will see moving forwards, some of our components will become more pluggable, allowing the operator the freedom of choice to plug in the technologies that they prefer. So how can you find out more if there are some things, you have some questions here that I didn't cover during this presentation? Well, you can please go check out our GitHub repo. If you're deploying, you're going to need to get Clone anyway. That's github.com/cloud-foundry/cf-for-k8s. And we also have, I'm delighted to say, a brand new website, cf-for-k8s.io. We've got some great information on there and lots of docs. So please go check that out. If you still have questions that aren't answered, then how can you get hold of us? Well, come find us in the Cloud Foundry Slack workspace, cf-for-k8s Slack channel, or the Release Integration Slack channel. Both will work. You'll get to the same team. If you have issues, then please raise them against our GitHub repo. And if you would like to contribute yourself, we have a contribution guide in our docs. Please go read it and please have a go at PRs. We love PRs. And just so you're aware, we will be making relevant announcements via the CF Dev mailing list. So please sign up for that. We'll also put those out on the cf-for-k8s Slack channel. Okay, and finally then, so cf-for-k8s, I think you've seen, provides useful abstractions on top of Kubernetes, allowing you to make the most of your clusters, saving you time and money. We are constantly folding the hard work, combined knowledge, learnings, and best practices from the entire Cloud Foundry community into the cf-for-k8s product, an opinionated developer and operator platform, built for Kubernetes, built for your org, built for you. The tagline has never been more true. Here is my app. Run it in the cloud for me. I do not care how. Thanks very much.